Major use of nitrobenzene is for the production of aniline, and this is what I'm going to be using it for. In this video, we'll be synthesizing nitrobenzene, but it's very important for me to point out that the nitrobenzene is extremely toxic and it must be handled with care. So with that being said, now we'll jump into the synthesis. The procedure that I used was the synthesis of nitrobenzene taken from Arrowwood. For the synthesis, I used 35 milliliters of concentrated nitric acid, 40 milliliters of concentrated sulfuric acid, and 30 milliliters of benzene. I also needed a little bit of calcium chloride as drying agent. 35 milliliters of concentrated nitric acid was added to a round bottom flask. With stirring was added 40 milliliters of cold concentrated sulfuric acid. The sulfuric acid was cooled by putting it in a freezer for about 30 minutes. To an addition funnel was added 30 milliliters of benzene. While the acid mixture was cooled in an ice bath, the benzene was added dropwise. It is important to keep the temperature below 55 degrees Celsius at all times. The reaction that we're carrying out is shown above. The mixture of sulfuric acid and nitric acid allow for the nitration of benzene to produce nitrobenzene. Because our goal is only to nitrate the benzene once, we keep the temperature low in order to prevent the dinitration and the trinitration of the benzene. This is not only for yield purposes, but also for safety, as the di and trinitrobenzenes are actually explosive. After all the benzene had been added, the solution was a faint yellow color and was heated to 60 degrees Celsius for 1 hour. It is important that the solution is not heated much more than 60 degrees Celsius. After the 1 hour, the solution was allowed to cool, and you can see that 2 layers have formed. The contents of the round bottom flask was then poured into a separatory funnel. The lower layer, which contains the acids, is drained away and discarded. The upper layer containing the nitrobenzene is washed twice with 50 milliliters of distilled water. Washing it with water allows for the removal of any acid that might remain in the nitrobenzene. Nitrobenzene is denser than water, so it becomes the lower layer, and this is the layer that should be retained. The nitrobenzene is slightly soluble in water, so the water does become a faint yellow color. Because there are trace amounts of the nitrobenzene in the water, it's important that the water is disposed of correctly because nitrobenzene is actually quite toxic. After the final washing, the nitrobenzene is transferred to a round bottom flask, and due to the presence of water, you can see that the solution is quite opaque. To further purify the nitrobenzene of water and of the di and trinitrated product, we're going to carry out a simple distillation. The fraction that started coming over at around 208 degrees Celsius was collected. For safety reasons, do not let the distillation flask get any hotter than 214 degrees Celsius. Also, it's important to not distill until dryness. As the distillate came over, it should be a cloudy white color because there's still water present in it. In the distillation flask, we're left with a thick brown goo. To get rid of any remaining water in the nitrobenzene, we do this by adding calcium chloride. The calcium chloride is added, the round bottom is stirred, and it's allowed to stand until the solution becomes completely clear. The calcium chloride is then filtered off from the nitrobenzene, and we're left with a nice crystal clear yellow liquid. The final yield of nitrobenzene was about 20 milliliters. This represents a percent yield of about 57%, which is actually quite low. The yield is probably quite low because I accidentally let the temperature rise to about 80 degrees Celsius instead of 60, which is pretty problematic. Unfortunately though, I didn't have more benzene to redo the experiment. The typical yield of the nitration of benzene is, however, generally around 80 to 90%.